Okay, now let's look at this question. A train moving at speed of 40 meters per second sound its whistle. Okay, sound its whistle, which has a frequency of 5 exponent 2 Hertz. Determine the frequency heard by a stationary observer as the train approaches the observer, given that the speed of sound in air is 345 meters per second. Good. First of all, we must identify who is the observer and who is the source. Okay, who is the source and who is the observer. All right, the train is making a sound, sounding its whistle. The train is sounding its whistle. So the train is the source. The train is the source. And then who is the observer? The stationary observer. The stationary observer. This is the observer. Okay. And then he say the observer is stationary. So we can say the VO is 0. This is the observer, and the observer is stationary. Stationary. So who is moving? Who is moving? The train is moving. The source is moving. Source is moving at a speed of 40. So this is the speed of source. Okay? Okay. So this is the speed of source. Now this is the which has a frequency. This one is the actual frequency. Or we can say the source frequency, the actual one. The actual source frequency. And then he asked to determine what is the frequency heard. Frequency heard, or we can say frequency observed. Frequency observed by the stationary observer. So he asked to find FO, the observed frequency. All right. All right. Okay. Now, okay, what is the so we need to find the observed frequency, yeah, frequency heard by the stationary observer. Now, the train is moving at what direction? Is it moving? The source is moving towards the observer or moving away from observer? Here you say the train approaches the observer. You need to look for all these keywords. Yeah. So he said the train approaches means the source source towards the observer. Yeah. So the source, is moving towards. Source is moving towards the observer. So given the speed of sound in air, this is the speed of sound. This is the V, yeah, speed of sound, 345 meters per second. So check the unit. All in SI unit, meter per second. Yeah, okay, good. So now, okay, let us, we can draw a diagram like this. Okay, so this is the diagram. So here is, he said the source, the train. This is the train, approaches the observer. So train is moving towards, and we have VS. Okay, the observer is stationary. So this is source moving towards. Yeah. Okay. So what formula do we use? So remember our concept, source moving towards. Okay, this is source moving towards. Source towards observer. Okay, so source moving towards observer. So the wave is compressed. The wave is compressed. So when the wave compressed, more wave passes through the observer. More wave passes through the observer faster. So you should hear a higher observed frequency. The observed frequency should increase. Okay, and here below we need to make a smaller value. We minus. Minus with a smaller value. So this value be no. What I mean is here need to minus, so become a smaller value. Below here become a, when you minus, the value below here becomes smaller. So the observed frequency become higher. Okay. So remember, the source moving towards observer, the the wave is being compressed. The wave is being compressed. Okay, and our formula, the observed frequency equal to V, and then because he said VO is 0, okay, so at the top only V, and Vs is at the bottom because source is moving. Source is moving, okay, and this is Fs. Okay, so since source is moving towards observer, that means the wave is being compressed. When the wave is being compressed, the wave passes through, more wave passes through observer faster, so we can expect a higher observed frequency, so the value below here need to become a smaller value, so how to make a smaller value? We minus, when we minus, the value below here become a smaller denominator. When value divided by a smaller denominator, the observed frequency should increase. So this is our formula. Okay, so let's find out. So put in our value V, which is 345 divided by 345 minus our source velocity is 40. Okay, and then our source frequency is 5 exponent 2. Okay, and then let's calculate our observed frequency. Okay, so our answer is 565.57. 565.57 hertz. So that's it. Is the answer correct? Okay, no answer given, but I believe this answer is correct. Yeah, your observed frequency should increase. Yeah, it did increase. Last time is, this one is 500 hertz. This is the source, the source frequency or the actual frequency. But now the observed frequency has increased to 565. Last time is only 500. Now increased to 565 because the source is approaching. The wave is being compressed. The observer hear a higher. We can say the observer hear a higher observed frequency. It hear a higher observed frequency. The frequency. This is the frequency let out. This is the frequency let out by the source, but the observed frequency here a higher observed frequency because the wave is being compressed. Yeah. So you see, 565 is higher than 500. Correct lah. Okay. The observed frequency has increased. So that's all for this question. Bye.